You can probably say that the functions we've been looking at are ideal periodic functions, but we know in the real world, such as swing sets or pendulums, um, things that are periodic in nature usually come to an end. Springs will oscillate back and forth for a while, but then as time goes on, the oscillations get smaller and smaller until eventually the spring of the pendulum stops. And these are called damped oscillations, um, which are affected by a damping factor, which we're calling f of x here. And simply what you do is when you're multiplying a trig function by one of these damping factors, uh, so you can kind of see this as the function of x over 2 times the function of sine of x. So essentially, our damping factor is this right here, what we're multiplying the trig function by. And we're going to look at what the graph looks like in a second here. But my damping factor, f of x, is going to be x over 2. And we're also going to graph negative f of x, which is negative x over 2. And remember, both of these are just going to be linear functions with a slope of 1/2 and negative 1/2 respectively, and they're going to have y-intercepts of 0. So when I pull up my calculator, sorry for the skip there, it took me a minute to get a nice window for this, but let me see if I can graph that one more time. If I go to zoom trig, as you can see, there's my x over 2, my negative x over 2, and you can see sine is kind of stuck within those two lines. It gets smaller and smaller amplitudes as we come in here, and then the amplitudes get bigger and bigger again. It turns out that negative 10 and positive 10 give me a little bit better window for you to see that. So let me try that real quick and look at the graph again. As you can see, the sine graph is essentially stuck in between those two lines. So we'll look at one more example together. In the same way, we're looking at the damping factor for y equals x squared cosine of 3x, and hopefully you can see that those are the graphs of x squared and cosine of 3x multiplied together. So this ends up being my damping factor multiplied by cosine of 3x. So my f of x is x squared, and my negative f of x is negative x squared. So as you can imagine, we've got a standard parabola on top and an upside down parabola on the bottom that's going to sort of hold in my trig function. So we've got x squared and negative x squared. And now we're going to take x squared times cosine of 3x. And when I zoom with trig, you see there's my upper parabola. I didn't put a negative in there. So let's try that again. Zoom trig. There's my upper parabola. There's my lower parabola. And cosine of 3x is kind of crazy, but it does stick in between those two graphs that are my damping factor. So hopefully that was pretty straightforward and you can figure out the damping factor of y equals 4x times sine of x.